Good morning. Today we'll discuss about Gauss-Jacobi method. So Gauss-Jacobi method comes under iteration or indirect method. So first let's see what an iterative method is. An iterative or indirect method starts from the approximation to the true solution, and if convergent derive the sequence of closer approximation, the cycle of computation is being repeated till the required accuracy is obtained. Now let's see the condition for iteration method, that is convergence rule. A process of iteration will converge if in an equation of the system the absolute value of the largest coefficient is greater than the sum of the absolute values of all the remaining coefficients, that is the diagonal element should be dominated. So here we can see in the equation a11x plus a12y plus a13z is equal to b1, and a21x plus b22y plus c23z is equal to b2, and a31x plus b32y plus c33z is equal to b3. So here we can see the diagonal elements are greater or equal to the sum of the all the other coefficients in that equation. So in Gauss-Jacobi method, let's consider the system of given equation a11x plus a12y plus a13z is equal to b1, a21x plus b22y plus c23z is equal to b2, and a31x plus b32y plus c33z is equal to b3. Here the diagonal elements are dominated. Therefore, x is equals to 1 divided by a11 into b1 minus a12y minus a13z, and y is equals to 1 divided by a22 into b2 minus a21x minus a23z, and z is given by 1 divided by a33 into b3 minus a31x minus a32y. So the first approximation is usually given by x to the power 1 equals to 1 divided by a11 into b1 minus a12 y to the power 0 minus a13 z to the power 0, y1 equals to 1 divided by a22 into b2 minus a21 x to the power 0 minus a23 z to the power 0. z1 is equals to 1 divided by a33 into b3 minus a31 x to the power 0 minus a32 y to the power 0. Here the 1 indicates the approximation and the 0 indicates the initial value, and in general it is given as x to the power n plus 1 equal to 1 divided by a11 into b1 minus a12 y to the power n minus a13 z to the power n, and y is equals to n plus 1 equals to 1 divided by a22 into b2 minus a21 x to the power n minus a23 z to the power n. Zn plus 1 is equals to 1 divided by a33 into b3 minus a31 x to the power n minus a32 y to the power n, where n is equals to 0, 1, 2, 3 and so on till infinity, which is of the form x to the power n plus 1 is equals to b x to the power n plus c. So now we will see some examples related to Gauss-Jacobi method.
Hi, this is a Gauss-Jacobi method uses to find the solution of system of equation. Now we see the first problem. Solve the following system of equation: 20x plus y minus 2z is equal to 17, 3x plus 20y minus z is equal to minus 18, 2x minus 3y plus 20z is equal to 25. The condition for Gauss-Jacobi method should be diagonally dominated. That means you have to find the formula for x coefficient of x is greater than remaining coefficient of y. Now we write the formula for Gauss-Jacobi method. We write x, y and z. We also write the general form of x, y and z. We put the tabular column, write the first row iteration value and write x, y and z. Take initial value for first row is 0. Now calculate and find the value. So if the calculation is stopped until a same answer will come. Since fifth and sixth iteration value the same, the solution for given system of equation x is equal to 0.999, y is equal to minus 1.000 and z is equal to 1.000. Thank you.
Hi guys, let's solve the problem. Solve 27x plus 6y minus z is equal to 85. 6x plus 15y plus 2z is equal to 72. X plus y plus 54z is equal to 110 using Gauss-Jacobi method. First, we have to consider whether the diagonal elements are dominated or not. In first equation, x should be greater than or equal to y and z. And in next equation, y should be greater than or equal to x and z. In the third equation, z should be greater than or equal to x and y. After finding that since the diagonal elements are dominated in the system of equation, so we can apply Gauss-Jacobi method. Then form an equation x is equal to 1 by 27 into 85 minus 6y plus z. Y is equal to 1 by 15, 72 minus 6x minus 2z. Z is equal to 1 by 54 into 110 minus x minus y. We are going to find the iteration values. We substitute values in the equation to find x, y and z. We assume initial value as 0 for all x, y and z. As we substitute 0 in equation 1, x is equal to 1 by 27 into 85 minus 6 into 0 plus 0 is equal to 3.1481. Next, we are going to substitute x and z value in y. Y is equal to 1 by 15 into 72 minus 6 into 0 minus 2 into 0 equal to 4.8000. Then substitute y and x in third equation. Z is equal to 1 by 54 into 110 minus 0 in minus 0 is equal to 2.0370. As above, we are going to substitute the identified values. Substitute x is equal to 3.1481, y is equal to 4.8000, z is equal to 2.0370. To find second iteration, x is equal to 1 by 27 into 85 minus 6 into 4.8000 plus 2.0370 is equal to, if we got that 2.1569, y is equal to 3.2692 and z is equal to 1.8899. As we saw, like that we have to substitute until we get the same values. We get that 10th and 11th values are same, that 2.4255, y is equal to 3.5730, z is equal to 1.9260. Since 10th and 11th iteration values are same, the solution for the given system of equation are x is equal to 2.426, y is equal to 3.5730, z is equal to 1.9260. Thank you.
Hello guys, we can see the next problem. Solve the system of equation 10x plus 2y plus z is equal to 9. 2x plus 20y minus 2z is equal to minus 44. Minus 2x plus 3y plus 10z is equal to 22 using Gauss-Jacobi method. Solution. Condition for Gauss-Jacobi method should be diagonal elements. That means we have to find the formula for coefficient of x is greater than y and z. Now using the condition in this step, 10 is greater than 2 plus 1 and next y is equal to 20. 20 is greater than 2 plus minus 2, and third equation is that is equal to 10. 2 plus 3. As per the condition, convergence is satisfied. Since the diagonal elements are dominated in the system of equation, we can apply Gauss-Jacobi method. Now we write the formula for Gauss-Jacobi method. X is equal to 1 by 10 into 9 minus 2y minus z, and y is equal to 1 by 20 minus 44 minus 2x plus 2z, and y is equal to 1 by 10 into 22 plus 2x minus 3y. Jacobi method general form is very important. We put the tabular column, write the first row iteration and or value, and second row x, and third row y, and the fourth row z. Initial value first row is 0. Now calculate, find the value. So if the calculation is stop until same will come. Since 8th and 9th iteration values are same, the solution for the given system of equation are x is equal to 1.0000, y is equal to 2.0000, y is equal to 3.0000. Thank you.
We will solve a problem using Jacobi method to approximate the solution of the following system of linear equations. 7x plus 52y plus 13z equals 104. 83x plus 11y minus 4z equals 95. 3x plus 8y plus 29z equals 71. Now consider the set of equations and check for diagonal dominance. It is when the absolute value of the largest coefficient is greater than the sum of the absolute values of all the remaining coefficients. That is, the diagonal element should be dominated. Since the diagonal elements are not dominated here, the given system of equations can be rewritten as 83x plus 11y minus 4z equals 95, 7x plus 52y plus 13z equals 104, 3x plus 8y plus 29z equals 71. Now, as per the condition, convergence is satisfied. We can apply Gauss-Jacobi method. Now, we can rewrite the given equations for x, y and z, where x is equal to 1 by 83 into 95 minus 11y plus 4z. Y is equal to 1 by 52 into 104 minus 7x minus 13z. Z equals to 1 by 29 into 71 minus 3x minus 8y. And we write in general for n, where n is equal to 0, 1, 2, 3 and so on. The first approximation is given when n is equal to 0. Note, the approximation goes on till we get the same values. Here is the iteration table for the values of x, y and z, in which 9th and 10th iterations are same. Since 9th and 10th iteration values are same, the solution for the given system of equations are x is equal to 1.057, y is equal to 1.3672 and z is equal to 1.9617. Thank you.